if I write this equation in the form of augmented matrix, okay, if all the elements are diagonally dominated or not, whatever the value I got here, that is my x. And what about z? Z is nothing but the 0. If I consider the diagonal matrix, it is not diagonally dominated. So what I want to do, I just want to rearrange the equation. Hello to all, a warm welcome to my new session on solving simultaneous linear equation. I am your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So dear student, in my today's session, once again I am going to deal with how to solve simultaneous linear equation. Before going to start my today's session, let me to recall the topic what I have discussed in my last session. So dear student, in my last session I started with Gauss-Seidel method. Along with that, I have discussed some example problems. Now let me to recall what is Gauss-Seidel method and how it is going to work. So dear student, here Gauss-Seidel method is mainly used to find the approximate solution. And in this method, we are going to get the linear equation. For example, say x, that is 10x plus y plus z, which is equal to 30, then x plus 10y plus z equal to 40, then x plus y plus 10z, which is equal to 50. Now, if I consider this equation, see, I have 10x, 10y and 10z. Okay, all these are diagonally dominated. What I want to do? I want to find the x value, y value and z value. To find out x, y and z value, what I want to do? I want to simplify this equation. So what I want to do? First, I want to check that x, whatever the coefficient of x I have, that must be greater than remaining 2. That is summation of remaining 2 coefficient. So I have 1 plus 1, it is 2. Okay, so 10 is greater than 2. Now, if I consider y, once again 10y is greater than 2. And if I consider z, here 10z, that is 10 is greater than x plus y, that is 2. Okay, fine. Now this condition is satisfied. After that, what I want to do? To find the x value, I'm going to take x outside. Okay, when I take x outside, I'll get 1 by 10. Okay, then this is my b1, this is my z, y and x. Okay, when I take x outside, what are the things I have? I have b1 minus y minus z. Now, to find out y, okay, I'll take y outside. So, I have b2 minus x minus z. Now, to find out z, okay, I'm going to take z outside. Now, 1 by 10, b3 minus x minus y over. Okay, this is the way I'm going to find the solution for x, y and z. So here x, y, z are the 3 unknowns. So dear student, in my today's session, I'm going to once again solve some example problems by using Gauss-Seidel method. Now let me to consider my second problem, that is solve the following system of equation by Gauss-Seidel method to obtain the final solution correct to 3 place of decimals, and this is my system of equation. Okay, fine. Now what I want to do, if I write this equation in the form of augmented matrix, okay, if all the elements are diagonally dominated or not. Okay, fine. First I'll write 1, 1, 54 and 1, 1, 0. Then 27, 6, 1 and 85. And 6, 15, 2 and 72. See here, if I consider my first equation, see I have 54 in my third position and here 27 in my first position, here 15 in my second position. Okay, and see if I consider the diagonal matrix, it is not diagonally dominated. So what I want to do, I just want to rearrange the equation in such a way that I want to get larger value in my first position, then second larger, then third one. Okay, fine. See, the given system of equation is not diagonally dominant, and hence we have to first rearrange the following system of equation as follows. So here what I will do, see I have the 27. That means I am going to just rearrange this equation, and if I consider this equation, 27 is my larger value. Okay, so what I will do, I am going to place this equation in my first row. See, I am going to place this one in my first row. Now, and if I consider these two, okay, equation 1 and equation 3, see 15 is larger. Okay, fine. So this is my second row. Okay, I am going to rewrite the equation. Now see, this is in my third row. I just want to cross check that in my Gauss-Seidel method, they explain that whatever the x value I am going to have, that must be greater than remaining sum of two coefficient. So here I have 6 and I have 1. So here 27 is greater than 7. It is fine. Now if I consider this one, see 15 is greater than 8. It is fine. Now if I consider 54, 54 is greater than 2. Okay, now this equation is correct. Now I am going to apply Gauss-Seidel method. According to Gauss-Seidel method, what I want to do, first I want to find out x value. So what I will do, I am going to bring this 27x outside. So I'll write x equal to 1 divided by 27. Then this is my b1 minus y minus z. Now for x, it is b2 minus x minus z. And for z, it is b3 minus x minus y. Okay, fine. Now what I want to do, I want to start my iteration, and to start my iteration, what I want to do, I want to start with the x value 0, y value 0 and z value 0. Okay, and I'm going to start substituting. So it is my b1 minus y minus 0, that is z0. Okay, fine. When I substitute, I'm going to get the answer, that is 3.14815. Now for my next variable y, it is b2. So y is outside, and which are the remaining variables I have? That is x, then z. Okay, when I substitute the values, I'll get 3.54074. And if I consider Z, okay, I'm going to take 1 by 54 outside. Okay, that means 54Z outside. Then it is written as 1 by 54. Then 110 minus my X value. And it is my Y value. So it is my B3. Okay, and I'm going to get 1.91317. Now, X is 3.14815 and Y is 3.54074 and Z is 1.1317. Now, okay, these are the input to my next iteration. So, in my next iteration, see here, this is my B1, Y and Z. This is my B2 minus X minus Z. This is my B3 minus X minus Y. So, when I substitute X and Z value, I'm going to get the answer 2.43218. So, this is my X, okay, in my second iteration. And if I consider Y, okay, after substituting X, see here, I'm going to consider same X, okay, then Z value, okay, I'm going to get the Y value, that is 3.57204. And if I consider Z, see here, I'm going to consider present iterations, X value and Y value. And when I substitute X and Y, I'm going to get the Z value, that is 1.92585. Okay, these are my new X, Y and Z value, and these are the input to the next iteration. And in my third iteration, see here, this is my B1 minus Y minus Z. Here it is B2 X minus Z. Here it is B3 minus X minus Y. Okay, so here whatever the Y and Z value I have, that is from my previous iteration. Okay, and when I substitute, I'm going to get my new X value, that is 2.42569. Fine. Now to find out Y, I'm going to consider present X value. See here, the current X value, and I'm going to consider previous Z value. Okay, when I substitute, I'm going to get the answer 3.57294. Now, to find out Z, okay, I have B3 minus X minus Y. So, here I'm going to consider present X value and present Y value. And when I substitute, I'm going to get the answer 1.92595. Okay, now these are my new X, Y and Z value. Okay, and these are the input to the next iteration. And in my next iteration, see here, B1 minus Y minus Z. That in the sense, I'm going to take X outside. So, remaining is Y and Z. Here it is B2 minus X minus Z. Here it is B3 minus X minus Y. Okay, fine. For this Y and Z, I'm going to consider previous Y and Z value, and when I substitute Y and Z value, I'm going to get new X value, that is 2.42549. Now, from this X value, once again, I'm going to find out Y. So, this is my new X value, and I'm going to take Z value, that is from previous iteration. Okay, after substituting, I'm going to get the answer 3.57301. Now, what I want to do, I want to find out my Z4. So, here I'm going to consider present x value as well as y value, and when I substitute, I'm going to get the answer, that is 1.92595. Now see here, if I consider previous iteration, here it is 2.425. Okay, here it is 2.425. Okay, it is fine. And if I consider this one 3.572, here also I want to get 3.573. Okay, fine. Now if I consider previous one 1.925, okay, here also I'll get 1.9259. Okay, and if I cross check both the iteration, I'm getting same values. So what I'm going to do, I'm going to stop the iteration, because further if I continue the iteration, what's going to happen? I'm going to get the same answer. So what I'm going to do, I'm going to stop the iteration. So it may be observed that the solution in the third and fourth iterations, when approximated to 3 decimal place of decimal, is the same. And what is my x value? That is x equal to 2.426. Why it is 6? Because it is 54. So I'm going to make round figure. So it is 6. And y is 3.573, and here it is 1.926, because it is 59. So I'll make round. So it is 6. So this is the approximate solution. Now I'm going to have another problem under this method, that is solve the following system of equation by Gauss elimination method, and I have 20x plus y plus 2z, which is equal to 17, then 3x 20y plus z, which is equal to minus 18, and I have 2x plus 3y plus 20z, which is equal to 25. Okay, fine. Now I just want to check all the elements are diagonally dominated or not. See here, if I consider this equation, it is 20, here it is 20, and here it is 20. So all the elements are diagonally dominated. Now I just want to cross check. So it is 20 greater than 3. Okay, fine for first equation. And if I consider second one, 20 greater than 4. So it is fine. Now if I consider third one, 20 greater than 5, it is true. Okay, so all the values are diagonally dominated. See, these are diagonally dominated. Now, the equations are diagonally dominant, and hence we write them in the following form. So what I want to do, I want to take x outside, and when I take x outside, what is remaining? That is 1 divided by 20, then b1 minus y minus z, and for y it is 1 divided by 20 b2 minus x minus z. Now for b, that is z, it is b3 minus x minus y. So dear student, this is the input to the next iteration. That means I am going to consider this form in my next iteration. And dear student, in my next iteration, okay, I am going to start substituting the value, because I just want to start my iteration and I don't know what is my x value, what is my y value, and what is my z value. So what I will do, I am going to start with the initial trial solution, that is x equal to 0, y equal to 0, and z equal to 0. And for my x1 is 1 divided by 20, and it is b1 minus y minus z. So here b1 is nothing but the 17 minus 0 minus 0. So it is 17 by 20. Okay. And when I perform the calculation, I'm going to get 0.85, that is 0.85. Now if I consider y, okay, for this y I want to consider b2 minus y is outside, then x minus z. Okay, and what is the x here? Whatever the value I got here, that is my x. And what about z? Z is nothing but the 0. Okay, and when I substitute the values and when I calculate, I'm going to get the y value, that is minus 1.0275. Now I just want to find z. Okay, for the z, it is B3 minus z is outside, so remaining variables x minus y. Okay, and when I substitute the values, I'm going to get the answer 1.0109. Okay, now I got x value, y value, z value, and this is the solution for my next iteration. In my second iteration, see here, I have x value, y value and z value. And see here, this is my b1 minus x is outside, so it is y minus z. Now y is outside, so it is b2 minus x minus z. Now z is outside, it is b3 minus x minus y. Okay, and when I substitute y value as well as z value, I'm going to get the x value. And see here, for this equation, whatever the new x value I got, I'm going to substitute here. Okay, and when I substitute b2 value, x value as well as z value, I'm going to get the answer 0, that is minus 0.9998. And for z, see here, I'm going to consider this x value and this y value. Okay, and when I calculate, I'm going to get the answer 0.998. Okay, now I got new x value, y value as well as z value. And these are the input to my next iteration. And in next iteration, that is iteration 3, I have b1 y z, so minus minus. Here it is b2 minus x minus z. Here it is b3 minus x minus y. And when I substitute y value, when I substitute z value, and when I calculate this equation, I'm going to get the answer, that is 0.9997. And if I consider y of 3, see here, I have b2 and I have present x value, and I'm going to consider previous iteration z value. And when I calculate x of 3, I'm going to get 1.000055. And if I consider z of 3, see here, for this equation, I have b3 minus, I'm going to have the present x value and I'm going to have the present y value. And when I calculate, I'm going to get the answer 1.000002. Okay, now if I consider my previous solution as well as present solution, see, there is a approximate value. That means there is a similarity. Okay, so here, okay, finally I'm going to write the conclusion that, okay, x equal to 1, y equal to minus 1 and z equal to 1. Because see here, I have 1, okay, and here also I have approximate to 1. And if I consider previous one, it is approximate to minus 1. And if I consider here, it is once again minus 1. And if I consider previous z value, it is approximate to 1 and here it is 1. So I can able to write the conclusion that x equal to 1, y equal to minus 1 and z equal to 1. Okay, so these are the steps used to solve Gauss Gauss-Seidel method. Anyway, dear student, whatever the equation you are going to get, that should be written in the form of system of equation. Then you have to check that all the elements are diagonally dominated or not. If it is diagonally dominated, then you can start with the further process. Otherwise, you just want to make a arrangement that all the element must be diagonally dominated. Anyway, dear student, in my today's session, I started with Gauss-Seidel method with some example problems. Anyway, in my next session, I'm going to deal with Gauss-Jordan method. Until that, keep watching and keep learning. Thank you.